Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled CTB1, the Medulla Nebula. So what do we see here? Well, here we see what is known as the Medulla Nebula, for its distinct shape, perhaps like part of a human brain. And because different people see these patterns in different ways, it's also sometimes known as the Garlic Nebula. So two widely differing things depending on what you happen to see. So take a look. What do you happen to see in the image here? Now, this is an example of a supernova remnant, and that is what is left behind when a star explodes. So in this case, a massive star at the end of its life became unstable. Stars are a balance between gravity and pressure. They produce energy in their interior, which balances them from collapse against gravity. In the long run, gravity wins out, because it uses up all of the sources of fuel that the star can have, and eventually it becomes completely unstable in its core and it rips itself apart. Now, this would have been seen to explode here on Earth about 10,000 years ago. So at that point, early peoples looking up toward the sky would have seen a bright star that appeared in the direction of Cassiopeia, and would have seen a bright star that appeared there and was present for a month or two, visible to the naked eye, maybe even visible in daylight, because a supernova can be that bright that you can actually see it during the day. And of course, since then, the supernova has long since faded and the material continues to expand outward. And that's what we see now is this remnant that we're looking at. So this is the material, the layers of the star left behind and expelled outward. The core of the star remains as a neutron star at the center. Neutron star is collapsed center of the star, about the size of a city, but with the mass of a star. And it also, when it rotates very quickly, as the one does here, it becomes known as a pulsar, which was a first discovery of these back in the late 1960s. Now, we often look at these images and think you must have a very big telescope to be able to get an image like this, and that's not the case. You don't necessarily need a big telescope. In fact, in many times, too big of a telescope won't allow you to see a wide enough field to see the whole range of what you want to get here. So in this case, this is a relatively small telescope, an 80 millimeter or about a 3-inch telescope that was used with long exposures, about 84 hours worth of exposures, to bring out all of the details looking at the emissions from the gas here, and then putting those multiple images together to see what would come out. When you put them all together, you're seeing a lot more faint detail than would otherwise be visible in just an ordinary single image. So looking at this on the sky, you would never see anything but a little fuzzy patch in the sky. Longer exposures will bring out more detail, and a very long exposure like this, even with a very small telescope, can bring out an immense amount of detail about this supernova. So that was our picture of the day, titled CTB1, the Medulla Nebula. We'll be back again tomorrow for the next picture, previewed to be Volcano World. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.